Hello everyone and welcome back to the Boulby Mine. So I'm here with Jon Telling from the University of Newcastle, and one of the things that we've been doing down here in the mine is looking for signatures of life in salts and possibly even gas signatures deep underground. So Jon, tell us what you're doing down here a kilometre underground.
Right, Charles. Well, yeah, so as you said, we're really looking for biosignatures, using gases as a potential biosignature for life in these very ancient evaporite deposits that you get down here. Probably easiest to explain if I show you a little picture of what we're doing. Can we do this? Yeah, excellent. Okay, so what we've been doing is taking some samples of the various evaporite, the salt deposits that you get down here, and you can get potentially some similar deposits on Mars as well, which is one of the reasons we're interested in this. And we're taking these different salt minerals.
These are just crushed up salts.
These are slightly crushed up. They're still quite coarse. You can see, if you look at those, they're still, up to about a centimetre across, something like that.
Yeah.
Different salt minerals, such as polyhalite and halite. And then we're adding water. And this is what happens to them when you add the water. As everybody knows, when you add water to salt, you can dissolve the salt. And that's exactly what we've done here. Now, we're doing this in quite a more scientific way, where we're dissolving it in a purified gas atmosphere. And what this means is that we can actually analyze the gases that are given off from the salt.
So you dissolve the salt in the liquid and then you're essentially gassing it.
That's right, yeah. So the most interesting thing is if you get these little things called fluid inclusions within the salt crystals. Mm-hmm. And these little fluid inclusions could trap methane gas, for example, that's been trapped there for potentially millions of years. So what we're trying to do is dissolve out this gas, analyze it, see how much of that gas there is, for example, how much methane there is. And we're also looking at something called the carbon isotopes of the methane.
And that's what this machine is, right?
Yeah, and if you have a look at this machine's called a Picaro methane isotope analyzer. Because mostly methane's made up of two molecules. It's made up of not only what you might think of as normal methane, which has the atomic number 12, so 12 methane. There's another methane, 13 methane as well, which is there in much lower amounts.
Yep.
And microorganisms really prefer the lighter isotope. They find it much easier to use. Mm-hmm. So what we're trying to analyse is how much really of this light isotope is in this methane. So can we use it as a sort of biosignature for within the salt inclusions?
So the idea is that you get the gas out of the salt, you're then measuring the different isotopes of the gases in there.
That's right.
And then based on the isotopic composition, you might be able to tell whether it comes from life or whether it's non-life, whether it's, for example, the thermal breakdown products of something deep in the mine.
That's right. For example, oil deposits or a methane gas associated with hydrocarbons in the North Sea, for example, would have a particular isotopic signature, a particular ratio of the 12 carbon to the 13 carbon in the methane molecule. So while life tends to preferentially go for the lighter isotope. So if you have microbes which are producing the methane from an organic source, then you'd expect that to have a lighter one. So so it's not completely conclusive, but it can be a good indicator of where maybe to search for other signs of life.
Okay, so you would see this as a very powerful way of at least looking at gases that might be produced and then thinking about using other methods to verify whether it would be produced by life, for example.
Exactly right, yeah. I don't think you'd ever want to try and use one method by itself to be a definitive sign of life, but it can certainly be a powerful tool to back other methods up, I think, in consortium with others.
And how would you do this on Mars? You would go and collect samples of the rover or a human, would you, and do exactly what you're doing here?
You could do it in different ways. I mean, this is one very simple way. That's if you're looking at evaporite, if you're looking at salt minerals, and dissolving it can certainly work. If you're looking at other minerals which don't dissolve, you would then have to think about crushing it. And that's another technique we're using in a laboratory as well. So rather than dissolving the minerals, we're crushing the minerals and looking at the gases that come off in that way. So on Mars, you could do either using an automated system or a rover, or if there were people there, using people to do it.
So as well as learning about the possibility of signatures of life in the gases in the mine here, could this be useful, do you think, for understanding gases in mining, so Earth-based applications perhaps?
Yeah, I think there could be some applications. If, for example, the particular mineral, the particular salt mineral that the mine is interested in has a particular gas associated with it, trapped within the mineral, then maybe when they're drilling their boreholes, they can find the signature of the gas and know that that's where they want to target. So potentially it could have some economic implications as well.
Okay, and then eventually this would be something that maybe human explorers could take with them. So you've been going through the mine, you've been collecting gas samples and now analyzing them for isotopic signatures. I guess eventually you could head out across Mars in a rover and collect gas samples in the same way. Curiosity has seen pulses of methane, hasn't it, on the surface of Mars? So eventually you could imagine doing a similar sort of thing in a habitat on Mars, looking for gases.
Oh, absolutely. And I think ultimately, I think that's what will happen. I think people will be doing this sort of research on the surface of Mars, looking at the gases as a past record of life. Yes.
Okay, so thank you very much, Jon, from Newcastle with his team here. We're all hard at work using the Picaro instrument and looking for gases in the mine that might help us understand gases in a mining environment, gases in the deep subsurface of life, and then eventually maybe gases on the surface of Mars that might help us find out whether there was ever life on that planet. Thanks a lot.
Thanks, Charles.